Hello, welcome. Turn this off before it starts beeping and giving out. How are you all? Welcome back. We are into the second week. What is it? 4th of September. It's June, summer holidays, and next thing whiz, all of a sudden it is September. We're back in the swing of things. Anyway, look at once we're back in the swing of things, that's the main part of it anyway. So I think I've answered most of the bits and pieces and queries and requests and the likes, and I'm hoping that everybody is up and running on your NetAcad by now. If not, of course, send me an email. So for the minute, we'll continue on we'll just finish off what we were almost finished on Monday. We were using the Octal for your file permissions. And in the background, can I just ask, are you okay that you can, for anyone that is taking class live, can the usual little sound check? Can you see and hear me okay? I'm hoping so anyway. NetAcad, you are asking when is that due? The chapter exams will all form part of that 5% continuous assessment. So for you, the due date is the end of the semester. I'm not going to be recording grades until then. So it just gives everybody, I understand there's different circumstances. Thanks, Connor. There's different circumstances between work, life, study, balance. So all of that, and I completely understand it. So I'm not going to take any grades for that until the end of the semester. So hopefully that'll take a bit of pressure off, because I think I confused you there the last day by saying that to do that for today. So I will be continuing on. I'll be getting you to go from chapter 5 onwards today. I'll discuss that later on. But as for recording exams and results, that's okay. You can self-pace it, take it down go down through it yourselves. I think most of the errors have been resolved. It is they're changing over the system in September, so I was a bit afraid. I think it's September anyway. I was a bit nervous that we'd end up with major hiccups while if I started class and next thing there was big changes or issues or whatever it might be. So that's why I'm using the legacy system. So I know I said that on your Slack page as well. Just to remind you to go back and look at the legacy system. That's the one that we're running. So that's the NetAcad. And then we're back into the notes. So yes, work away and go down through. Do I have the web, the wonderful world of the web? Oh, let's share my screen a bit. There we go. Okay, so onto the web page. That's the thing from Monday. Don't say last week. Time flies when you're having fun. So in here on your labs, if you're new to Linux, I think this will benefit you to spend a bit of time going down through the labs, go down through the chapter exams in your Cisco NetAcad, because it all goes through the basics. It brings you from the ground up. Because when we get to the assessment, of course, you're all going to be graded based on the same level of knowledge. So it's just a great idea for you to get a bit of practice in. And as I said, I've been going down through the num user script and we're onto permissions at the minute. But in here, from creating scripts, from doing a bit of practical work, that's where the main skills are. It can be difficult to read reams of paperwork. I learn very practically. I'm one of those visual learners, charts and graphs and arrows here and there. But I think that working out and going through the practical side of the labs will really benefit you in terms of the skills that you'll get from your Linux shell scripting. So that was the first, that's the first class. And there to complete those chapter exams. So they will form 5%. So you can do those in a self-paced, but obviously it's going to be of more benefit to you if you try and keep up to speed with the contents before I give you any assessment. Okay, just get this out of the way and it'll give you a great grasp, I suppose, of the Linux and the shell scripting and the commands and how to use variables and call them and running the scripts and permissions and all the rest. Speaking of permissions, that's where we were last week. So for you, we got as far as 13 on this, which is here, okay, around there. So your chmod, which will allow you to change the file permissions on a file. Everything is a file in Linux. Directories are files. Here we go. Right. So in here, when you're changing the permissions, when we go to run a file, I told you that it's good to have your Linux open in the background. Should take a leaf out of my own book. No, not Visual Studio. Oops. I am running VirtualBox, so it just takes a minute to open it up in the background. In here, so we have our, when you run a command on your terminal window, whatever terminal window that you're using, by default, your scripts, any automated script, will have permission denied. Okay, so that's where you need to be able to change the permissions to whatever you want them to be. So in here, in this case, we have chmod 755. 7, remember octal, we're working with octal values. So we have 0, if you use your fingers, up as far as number 7 is as far as we can go in octal, because 0, 1, 2, 3, 4, 5, 6, 7 is 7 digits. Okay, so if you have 7 digits representing one octal digit in here, if you want to turn on the 7, think of that as your read, write, execute. And you've got your 3 ownership groups of any file. You have the owner, that's usually yourself. The group then, so as I said the last day, if you were part of a group, let's say I could read files maybe that have student numbers in it, but I can't edit them. So you can see the way there's different permissions needed, as you can imagine. So the group then, maybe I just need to read it. I shouldn't be allowed to do anything else with it. And then the others for anyone that you're sharing a file with. So you have your octal permissions for that. And your variable or your binary, they're all like switches, turning them on or off. So you want to turn on read, write, execute, 111. And that will convert into 7 in octal. So 111 is represented in octal as 1 digit. That's the advantage. It's just convenience. Where you have your binary, which would be 9 digits, you're just splitting it, and now your computer is only working with 3 digits here in octal. So you've got your 3 categories, your owner group and your user group and others. And you have your switches, read, write, execute. The next one for the group, here you can see that read is turned on, write is turned off, and execute is turned on. So they're allowed to read and to execute. And similarly, the same thing with the others. They're allowed to read. They have no permissions. It's switched off, or it says 0 for write, and then they can execute. They can run whatever file it might be. Okay, so in terms of that, that's the octal digits for it. So again, you're very much basing it on this look. It's just, think about it as being, you've got 3 switches, read, write, execute. Which ones do you want turned on or not? This 4 plus 2 plus 1, remember that's the first, if you have the number 111 in this case. It is 2 to the power of 0 multiplied by 1, 2 to the power of 1 multiplied by 1, or by 2, and 2 to the power of 2. That's your 4. Multiplied by 1. They're all multiplied by 1. I think I said by 2. So they're all multiplied by 1 because that's where your ones come from. I'm saying that because when you get to octal, and if you are converting digits, you'll be multiplying it by 8. If you're in hexadecimal, you'll be multiplying it by 16. So in binary, it's just 1 multiplied by, and then you have your, what's called your positional weightings of it. So 1 multiplied by 2 to the power of 0. Then it's 1 multiplied by 2 to the power of 1, and 1 multiplied by 2 to the power of 4. Similarly with this group 101, it will be 1 multiplied by 2 to the power of 0, 0 multiplied by 2 to the power of 1, if you were writing it down, plus 1 multiplied by 2 to the power of 2. So if you wrote those down, they would all equate to these weighted numbers. So 1 or 4 plus 2 plus 1, because they're all switched on, that gives us 7, and there's our octal variable. Similarly with this, if you were to write out those, read, write, execute, put in a 1, 0, 1, you're turning on read, you have no write, and you have execute turned on. And you do your, again, convert your numbers, your 111, I need to convert those into decimal. What is 111 in decimal? Or 101, I should say, for this particular one. We did the 111 on the 7. So here it would be 1 multiplied by 2 to the power of 0 plus 0, because I have that switched off. 0 multiplied by, it doesn't matter what I'm multiplying it by, because 0 by anything is 0. So that's why we can omit anywhere that there's a blank or a 0, or if you don't want it turned on. So it's just, then you have 1 multiplied by 2 to the power of 2. So 2 to the power of 2 is 2 squared, isn't it? And anything to the power of 0 is itself, is 1, sorry. So in there, 4 plus 1 is 5, and similarly with that. The easiest way is just to write down and have a look at it. So there's your octal representation. 4 is read, 2 is write, and 1 is execute. Do you get it? Why is that? Why is 4 for read? For any of you that are live online, what is the answer to that? Why is 4 read? Why is 2 write? Why is 1 execute? So if I want to turn on execute permissions, it would be 1 plus whatever other permissions I want. Why? Why are those values there? The 4, 2, 1, 4 plus 0 plus 1, 4 plus 0 plus 1. What are we converting those between? Okay, so if there's anyone on live online, Duffy, the live line is open. Right, so why is that coming up? Now moving along. Hint. Your binary and how to convert into octal values are in the table there. Your octal values can carry a maximum of 3 positions, because if I fill up each of those, so you obviously can start with 0, 0, 0, which is up at the top, and you can go as far as 1, 1, 1, because you're only working with 3. Yes, Connor, that's right, with your binary, you're converting them, aren't you? So in here, they can go as far as 7. That's when you've got all switches turned on. Think about light switches. If you had 3 light switches, what's all the possibilities that you might have? You might have all turned off. You might have off, off, on, off, and so on. So once they're all turned on, I can't do any other options with it. So you can see then that down here, binary and octal, this one, which looks a bit weird, the one I have here, 1000. What is that in octal? Well, you split it into. Let me get this little pen. Got to get a battery for my other actual pen besides for the mouse. Where are you, mouse? Here. Right, so if I was to split that as carefully as I can, it's 2 different octal digits, because you've only got 3. You can only go as far as having 3 of them. So now you've got 2 groupings. You've got 2 groupings. The one on the, where's my pen? It's so tiny I can't see it even. I'll go back into my laser. So in here, 0, 0, 0 is just 0. There's my 0 on that. And then 1 is the same as saying 0, 0, 1, which is here. There's 0, 0, 1, which just means 1. So now my octal representation of binary 1, 0, 0, 0 is 1, 0. So these numbers aren't 10, 11, 12. We're not talking about decimal. What we are talking about is octal representations, and it just means you've got 2 groupings of numbers. So that 0, 0, 0 is the same as the 0, 0, 0 that we have up there. Okay, so that's your first one that you've got. And then for the other one, if I just change the color, the second grouping then is this 1 that we've got here. So 1 is the same as 0, 0, 1, which is this one up here. Okay, if you can see my scrolls. So your octal representation, what we would usually just read as 10, 11, 12, 13, 14, it's actually not. It is there's my second grouping. So this grouping, your octal representation is 1, and the red one, the octal, my little tiny pen again. In the other one, the octal representation is a 0. So that's where that 0 comes from. So that 0 just means 0, 0, 0, and the other one is 0, 0, 1, right? So that's the circle of life that we're working with here. So you can split them. Similarly, if I go to 14, the first 3 digits, sorry, I said 14, which I'm just telling you, it's not 14, it's 1, 4. So there's my 1, 0, 0. If I'm splitting it again, so if I split that grouping, just to erase some of those. So if I split that grouping, we have digits 1 and 4. Why is it 4? It's because the first 3 digits, 1, 1, 0. If you look up here, that's the same thing, isn't it? Okay, there's my wonky arrow. So, and then 0, 0, 1 is the same as all of these. They're all just representing the number 1, which is the digit 1. Not a decimal number. Confusing myself. Okay, so in there, when you're working with octal, you can have a maximum of 3 positions, because once those 3 positions are full, 1, 1, 1, you can't do any further. You can't go any further. So then you add in a second group to the left hand side of the grouping. So you can see, where's my little tiny mouse? You can see here, these are all a second grouping, group 1 and the second grouping, right? So it's 1, 0, 0 is the first, and that's where your 4 is represented. Similarly with 0, 0, 1, what's that? I don't know why that line goes up the way. And that just represents 1. There's the same thing as the other one, 0, 0, 1, which is like saying 0, 0, 1 here as well. So they're split into 2 groupings, and that's where your octal variables have 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, and then we're in again into changing our parameters or changing our groupings. If you had a look at this, show that 7 in, see these subscripts? If you're used to using Microsoft Word, you have superscript like X squared, and you've got these subscripts. So if you're into Word documents, these are called subscripts, or into any documents. So this means we're representing octal numbers, and this means that the 7 is a decimal. So show that 7 in octal is equivalent to 7 in decimal. So the weightings where we had back in some other page, if I just flash back there for a second, where we had this weightings of 2 to the power 0, 2 to the power 1, 2 to the power 2, and wherever you put a 1, that's where they're represented as 2 to the power 0. So it'd be 1 multiplied by 2 to the power 0, 1 multiplied by 2 to the power 1. In our octal, in here, convert 7 in octal. Let's see what that is in decimal. So you could say, where I said it was 1 multiplied by 2 to the power 0, this time it is 7 multiplied by, it's my octal value, 7 multiplied by 8 to the power 0. So instead of 2 to the power 0, we're working with octal, which is my 8. 8 to the power of 0, 8 to the power of 1, 8 to the power of 2. So it would look exactly the same as this, except for this top column here up on the very top, the red one, would read 8 to the power of 0, 8 to the power of 1, 8 to the power of 2, and so on. So for that, we have the number 7 in that first position. So where I said it was 1 multiplied by, because binary works in only 0 or 1, this time it is 7 multiplied by, and we're working in the first position, 8 to the power of 0. So 7 multiplied by 1, anything to the power of 0 is equal to 1, okay? And that's a very common mistake when people are converting. And then it's in here that it is itself. So anything to the power of 1 is itself. And there is why, and that is how your octal value looks the same as your decimal value. Okay, so adding, if you were to put in any extra ones, then if you had bigger numbers, they would also work out in the exact same way as what you did with binary, except that this time you're multiplying it by 8 to the power of, and wherever your positions are. So CH mod runs from 000 up to 777. And that's the main reason, the only reason that I ever use octal permissions, or octal is in file permissions. So it's just one way to represent permissions in any Unix-like system. You could use this symbolic notation of, or what you can see there, this read, write, execute, read, write, execute. Let me turn back on my little laser pointer again. Okay, so in here you have this read, write, execute, read, write, execute. Or else you could have, like what we did on Monday, you could just put in a +X and it will give everybody execute access. So they're shorter ways if you know that you want all users to have read access or write access or whatever, execute access. So for your scripts, it'll be fairly common that you'll use 777 if you want it all, or 755 if you want it. There's that 755. Read, write, execute for yourself, but everybody else can read it, they can see it, but they can't make changes to your files. So it's just about whatever way you want to make your files as safe as possible. Just a brief look at hexadecimal. We won't be doing too much with hexadecimal, but I'm aware that you would have used hexadecimal for HTML color coding. That's really where you see it. So these long binary numbers, of course, is what the computer hardware. It's all having a pulse or it doesn't. It's electricity. So yes or no answers. There is a pulse, there's an electrical voltage, or there isn't. So in this, at the hardware level, you have so many ones and zeros. And what hexadecimal does then is you can represent 0 to 9 just using the same symbols as you can see here. And then, as you know from your color schemes, it goes as far as decimal 15 by using A, B, C, D, E, and F. Okay, the primary reason is, again, for user friendliness. So it's a more convenient way for us to be able to represent binary data. Far more compact, far more human readable. So we can see if you want blue, red, green, blue, and different weightings of it. Instead of trying to remember how many zeros and ones that you had, you can use, let's say, the highest value of FF or the lowest value of 00. In computer memory as well, that's where you'd see hexadecimal system. So in memory, they would use that for computer systems and the addresses of memory. So memory addresses would be used in hexadecimal as well. But for you, more than likely, this is where you've seen it in color coding, where you have different colors, red, green, blue, very common, and you can put in your different values of it. So that is file permissions, okay? Octal is probably the main reason that you'll use it is for your file permissions that you'll be using on your shell scripts. We'll be coming across it plenty of times, so you don't need to worry about how am I going to remember chmod. You'll use it enough times that you won't need to worry about that. And it's the same with most of the common commands that, like this ls-l. Maybe you never put that into a file before, but all of a sudden you'll become far more familiar with it. Turning on my Linux there in the background. Okay, that is your numbering systems. I want to discard my ink. All right, so from that then, what we want to move you along then into, where's my computer is, kickstarting there. Okay, so in there, I'm just going to swap around and open up the second part, or the first part of today. And the first part of today is going through some common commands that you will use as well. So I have my Linux open in the background. Well, at least it should be by now. And today there's recap. We didn't even need to recap. I've done that with you because we're just after going through it now. So your chmod and you have your ls-l. So ls-l will allow you to read your file. I can turn on my laser. So your ls-l allows you to see. So your ls is to list all your files from wherever you are, your current directory. -l means a long listing, so you get to see all of the permissions and the time and date stamps and file size and so on. And then the st star means list out in long form any directories, any files that, not directories, any files It could be directories, it might and it mightn't be. So any files that begin with ST and I don't care what's after it. There's my wildcard, your star. That's your wildcard character. So in there you can see that those values or that output, it's not a directory, it's a file because there would be a D there otherwise. It has read, write, execute. So you can see the first three groupings, the user is read, write, execute. So that would be chmod 7. Next one is read, no write, and execute. So it'd be 101. There's my 101. It's 4 plus 0 plus 1, which is 5. So far I'm at 7, 5. And my third grouping is no read, no write. So I know they're going to be zeros, but I want to allow execution of the file. So in that sense, we have 0, 0, 1, 1 multiplied by 2 to the power of 0, and 2 to the power of 0 is 1. So in there, all you're doing is adding up 0 multiplied by, which is nothing, 0 multiplied by, which is nothing, and 1 multiplied by is the number itself. So there we go. We have 751 would be the chmod, which is done up on top there. Moving along, there's my little, I forgot my lovely little animations after putting them on. So there's your 001. Okay, for this week, what I will be getting you to do is on your Netacad, and again, this is with a view to you doing it in your own time, so you don't have to complete it for Monday's class. It's not going to affect the running of the class. So, but if at all possible, we're going to keep up to speed, and you're going to try and keep up to speed with the chapter exams that you've got here. So chapter 5, I'm going to bring a bit of that into the class. Okay, so that'll all be complete as part of. So your command line skills then, of course, you've done programming. So you have your basic loops and your while loop, your if statement and all the rest. You will have those as well as having a shell that you're going to interact with. You've got your commands such as ls. You've got your variables. Do we use any variables yet? We use date. That will be a system variable. I didn't set date equals. Okay, so that's a system variable. You've got your different command types, your quotes and your control statements. Your quotes, using different quotes like that little tick mark that hopefully you've all found where it is on your keyboard. And then you've got your control statements, your if statement, your while loop, your for loop, and so on. Right, so moving on. Your command line. I'm going to zoom through this. This is from the Cisco Netacad website, so it just gives a bit of an overview of it. So your Linux community promotes the command line interface because it's very powerful, it's very speedy, and you can accomplish a bigger variety of tasks with a single command. So what we will be doing is setting up shell scripts then that will allow us to run longer commands automatically. Your command line allows you to have more precise control. It has greater speed, of course, and you can automate your tasks by putting them all into files and running them at a particular time, or running them every morning, or running them whenever you want it. So by learning about and being comfortable with the command line interface, you can be very productive almost instantly once you get into it on any flavor. As I've told you, it doesn't matter what flavor of Linux, what distribution you might be using, the command line interface is going to be the same thing. The shell, what is the shell? The shell is just basically where you put in your commands. It's how you interact with the overall operating system. So once a user enters a command, the terminal accepts it and passes it to the shell. So your command line interface gives you all the control and the speed and everything. So your shell then is your command line interpreter. It's what interprets all of the code that you will have written. So you'll enter in the code, you'll have your actions, you want them to be performed, and it's the shell then, that code gets transferred and given to the shell, and that will interpret all of your commands. Linux allows for the use of many different shells. For the purpose of the notes and this class, we're going to use the bash shell. It's not going to make any difference for the purpose of what we're doing, but it's the most commonly used shell, and that's why I'm going to stick with that. So in there you can see this is your shebang line. We mentioned that the last day, and here's your comment. This is a description. So in general, like with any good programming practice, you should have a description of what the code will do. And there's what we did the last day, or Monday. Your date, your who, and instead of printing out who's logged in, it will send it or pipe it into the command called word count minus L. So it'll count the amount of lines that the command who has output. That's like a tongue twister there. Okay, so instead of writing out the names, you'll get it to count the number of lines of that output. And that's what your WC minus L will do. And then your PWD, as we used the last day, is your print working directory. So your bash shell, loads of popular features. You can go through your history of all the commands that you've used, which I'm forever doing, so that it saves me from trying to find or trying to write out a longer command. So you have your command line history. You can edit. You can use your forward and backwards arrows, and you can edit on the line. You can create scripts. You can create aliases, which are just nicknames. If you have big long commands, you can set up on your shell to have it as a short. So you can call it whatever it might be. Logged in, and then get it to run and check how many users are logged in, and maybe if there was any issues, whatever you wanted to do. And then when your terminal window is run and the shell appears, that'll display a very important part of your interface, which is called your prompt. And a lot of times in my notes, you'll see I have a little $sign written at the start of notes. Generally, unless you think we're talking about American dollars, but generally that $sign just represents the command prompt, doesn't actually represent the dollar symbol. Okay, so the prompt shows the username, the system name, and the current directory. And you see that little tilde sign? That's your current directory. So it's used as a shorthand for my home directory. So for example, which can be handy as well, check that you can see that. You can. I just open my terminal window. Yep, execute it away. I'll just use that tilde sign. So there you'll see, and again in a lot of my notes, you'll see that little $sign, and it just means it's where the commands are, or it's where the prompt is. So in here, if I told you the last day, so if I go to ls, and there I can see, click into it first. ls or ls minus L gives me a long listing. So if I change directories, change directory SEP, I know that's the only one with SEP, so I can do a star instead of having to remember what's underscores or capitals or lowers. So I'm CD into that, and if I had directories inside that, I could change directory into those, going one level further down the tree directory structure as we go. If I want to get back to my home directory, so let's see, there's my PWD, print my working directory. There's where I am. I'm saying, oh God, I want to just quickly get back into my home directory. CD tilde will allow me to do that. So now if I use my up arrow, there's where I'm talking about with history. I can do PWT instead of me having to type it again. It is only short, but just to show you where they are. So you can see all of that up arrows for the last used commands. So PWD shows me I have moved from using my CD tilde. I've moved from being inside the September 24 into being on my home directory again. With your commands, I just did one. I use my ls. So your command is any program that performs an action, as you can imagine. So you execute it, you type it in, right? So typing your command, whatever it might be, if it's ls, if it's pwd, if it's cd for change directory, any of those are commands. And with commands, you can sometimes be required to put in additional information. Otherwise, you have optional, most of the time you have optional arguments, like what I'm saying with that ls. I can use ls, it works perfectly fine on its own, or I could decide that I'm going to put in ls minus L, because I have an option to put in the minus L, which allows me to see a long listing. If I'm not too sure, how would I do something? Put them in alphabetical order, sort them somehow. I can do man ls. Remember that from the last day? There it tells me there's my name, synopsis, and I can scroll down. Oh yes, don't ignore that. There's the escape characters, there's the block size, and so on. So I could scroll down through that. I'm just pressing enter to scroll down to it. And there you can sort it, show, hide, list the entries by columns, and so on. And at any stage of this, I can press Q to quit. Unless it is frozen or there's an error, you don't need to use that Control C. So Control C is to cancel out of it if there's an error. So that's your commands. And as we have said, there's optional arguments. Okay, so in there you can have an argument that you can add on to your command. So if the ls command is given the name of a directory as an argument, it will list the contents of that directory. So in other words, if I knew that, I wanted to check what's in my September 2024 file, I could say list ls, if I could spell, list what's inside that September directory. And when I do it, it lists out first script and a directory called stats. I could ls minus l and tell it, I'm just going to use my up arrow to saves me the time, ls minus l, and it'll just give me the same thing but a long listing of it. But you can see if I do it without the SEP at the start of it, it just lists where I currently am. Another tips and tricks, right? So you can get it to do more than one by just space separating. I can have list, tell me what's in September, and also tell me what's in my videos directory. And there it lists that out. So it tells me what's in my September and also what's in my videos. So it sees both of them, and that's why I said Linux is case sensitive and space sensitive. So because I have a space there, it sees, and so I'll do this first, and then I have something else to do. I have another action to perform, which is to also ls minus l what's in my videos file. Okay, and back in the game, we are into options. You can modify how commands behave by using optional arguments. Optional tells you by the name that you don't have to use it. So the likes of your minus L, or what about if we did ls minus L, or get rid of the videos because that doesn't have anything in it anyway. So if I change that to minus, I'll still use my minus L, and I can add on an R on it. And you'll see for some reason they've swapped positions because the R or minus R, I could, but it's inefficient. I could say minus L space minus R and it will give me the same output, but it's inefficient coding. So I want to put in two optional arguments, one being the minus L, one being the minus R, but I can group them together and write in minus L R. I could say, and also I want to make sure there's no hidden files, so I can say add in the minus A optional argument. So if there was any hidden files, any starting with these directories, it would show them as well. So your options can be used then in conjunction with any other options. You can group them together. Okay, so there's your minus R. You could have minus H to make it human readable. If you look at any of the differences with those, that is another nice one to use. So I'm seeing, what's 4096? I don't really know what that's talking about. So instead of the minus, instead of all of that, I can also add in a H to make it human readable. And there, 4096 now changes to 4K. So it shows me the size of files. And the H stands for it being human readable. Okay, that's all that means. You can sort them by time, which is, again, if you go looking up, so I can keep on adding on loads of these. It doesn't matter what the order of them is, because in this case, it is sorting it by time. And that was sorting it by time with reverse. I can take out the reverse, get rid of my A, or my R, I should say. Get rid of my A because I don't want those hidden files, and so on. Plenty of those. And again, that's what the man files will help you with. Variables then. Allows us to store data, of course. We need to be able to store variables from your programming experience. Otherwise it can be impossible to create a program. You have what's called local variables and environmental variables. Local variables, if you are working on the command line, a local variable means that if I set a variable, right, if I'm in here and I set a variable, you don't need to define variables like what you might have used before. I can say x is equal to 64, right, whatever it might be, and then I can tell it echo x. I'm wanting it. I made a mistake. I know that, because when I go in here and tell it to echo x, it will say, okay, I'll echo x. If I wanted to call echo the value of, that's where your dollar sign comes into play. So just to show you that. So now it's showing me the 64. So I have a value. I have given x a value. But because I'm only using this on the command line, that's an example of a local variable. So it's existing only in the current shell as I'm using it. So that x being equal to 64 will disappear then after I've exited this. So there you can set a variable, don't need to define it. So you can create a local variable called variable1 or hello or welcome or x is equal to, and then you can display it. And again, if you want to call the value of a variable, that's where your dollar sign comes into play. Again, practice makes perfect. So if you were just to echo variable 1, it will echo the word variable 1. Whereas if you wanted to echo back the value of the variable, you put the dollar sign before it. Again, you'll be using that every single time you use variables, so don't worry if it all sounds a bit overwhelming. In another week, it'll hopefully be a bit more settled, or you'll feel a bit more comfortable with it anyway. Your environmental variables then are the system-wide variables. The ones like path, the ones like user, the ones like env for the environment. They're part of the system. I don't change them, I don't set them. I don't turn on my computer and say, let me go into my Linux again. So if I go into echo here, echo my variable, that's grand for x. But if I say echo the user and Caroline C comes up, I didn't set that. That's set and owned by the system. Okay, so that's what environmental variables are. If I was to see the ones that are on the notes, then echo or echo what have we, the history. HISTSIZE. And you can see they're all in capital letters. If I say echo hist size, what could that mean? Whereas if I put that in lowercase, HISTSIZE, it's saying, I don't know what that is. I don't hold a variable, so there is no output. So this capital HISTSIZE, I didn't set it to be 1000, but what it is the history. So it's the size of how many I can keep on. You see here, this is my history of all of the previous. If I use my up arrow, I can go up through them all, and there it'll run back through the variables that I've used. So since I've downloaded or started using this version, I've 108 stored in history. But you can see when I echoed the history size, I will be allowed to store 1000 different commands in there that I've used. Okay, so the command in the example displays the variable, the value of the variable. And in this case, it's an environmental variable. I didn't set it. The environment did. The operating system did. Your path, where are you? Right? In there, your path variable is all the place that the system can look for programs to execute. So your path is where everything is. So it tells your Linux shell where to look for executable files. So in there, I can echo the path, and it says all of my environmental files are stored in there, and all of my /this, /that, and then at the end I can see bin, which doesn't mean the refuse bin, it means binary, and that's where my binary executables are stored by the system. So sometimes you might want to install programs into other locations on your computer, but you have to be able to execute them easily. You usually don't need to have to specify the location, but if you need it, you can add a new path into this. So you can force it onto it. Okay. I mentioned as well that when you're doing ls and when you're moving down through directories, it's in a tree structure. So I know I just did the command tree there the last time. So if I do a tree, oh, click into it. Where am I? Hello, wiki. I have died. Anyway, I keep going. I was just going to type in TREE, you can do it yourselves, and you'll get this type of a look, except for if this is going from top down, it goes from left to right on your command line. So in here, your file system hierarchical structure. So up at your home, you've got all of these directories, and inside these directories contains the files, whatever they might be. Like your bin that I just said is your executable binary files. So when you type a command into the command prompt in Linux or any other Linux system, all you're doing is telling it to run a program. So a simple command like make dir or ls that you've used loads. They're just small programs, and usually they live all inside this bin, this binary folders. So unit 2 in your class notes, not your class notes, in your practical. I'll just come back to that. And in here again, you have some examples of getting a bit of structure on things, getting a bit of understanding of what's happening and what you need to be able to do. And what I'm guiding you towards being able to do is to understand your way around an operating system. We're using the Linux operating system. We're going to use the command line, and it's about you being comfortable with finding your way around it, not being afraid to experiment, but making your way around even this file system structure, this file system hierarchical standard, whichever way you want to call it. So in here, it's this tree structure that you are up at the top, and you can create a directory called comp.sys. Inside that, create a temporary one. So you can see I've given you all of the how-tos and I've given you the code for them. The $sign at the beginning, you don't type in the $sign. That is your command prompt. Unless you think we're talking about value of currency, usually this $sign, or there will be a few exceptions where you need to use it as well, but in general, this $sign just represents the command line prompt. So there's your man page, there's creating a few directories, and what I want you to be able to do is to create a directory structure like what's on the overhead there. So you're going to create comp.sys. Inside that you'll have a temp directory, inside that you'll have a tutorial directory, and inside that you'll have September, October, December, with December containing another directory called finals. Absolute and relative paths then are, do I have them? So your absolute and relative paths, which are up on your practical labs as well. Sorry, just open that. It's just how to get to them. Okay, so being comfortable with moving your way around, going down into a particular directory, coming back out of it, moving something that's down 3 levels under where you are, pulling it back up to where you are, or maybe pulling it back up and then moving it down another 2 directory levels. So this up and downs, I'm referring to this tree structure, this file system hierarchy, and it just allows you to move up and down through. So wherever you are, if I was sitting inside this comp.sys folder, how do I know where I am? Because pwd is the command, print working directory, will show you where you are. And you should be able to /tmp /tutorial /dec, and that'll bring you down into that. Similarly, .. brings you up a level. And if I continued that and did cd, change directory, space, .. that will bring me back up 3 different levels. So your paths there are all on that, navigation through them. and renaming and removing files. To do that, renaming them, I use it on Monday. Your MV, you might be in the directory, which is perfectly fine. If not, you might need to say move MV, in other words, rename. Let me go back up here and I just copy this. If I said MV/temp/tutorial/myfile1, and I can just use a space, so it's like having move source to destination, and my destination can be a full path, or it can be just moving it from the same places where I've started out, so it could be the same pathway. So I can just move, which means to rename files, so it'll delete the old versions. Obviously you can't rename them if they're in use, the same as what is usual. And removing them with your RMDIR, if it sees that the directory is empty, it'll remove it. If there is content in the directory, it will give you a little warning, or it won't allow you to just delete it as easily. And there's your navigation basics. There's some relative file paths, and again, definitely worth your while on going down through that practical, making yourself more comfortable with where you are, how you can get to a destination, and how you can go from a destination back up to home, or maybe down into a different directory level. So there's your absolute paths. Your shortcuts, your / at start your path means start from the root directory. And similarly, your tilde means start from my home directory. So from wherever I am, I might be down I could be down in that directory called December. And then I might want to say, oh, move that or rename that file that's in the September directory. By using your tilde, it saves you doing .. to get back up to home and then going back down another branch. So instead of that, you can simply use your tilde, so you know you're starting from the home. So again, there's your clear, we've used that. There's your history, we've used that. The up and down arrows will allow you to move down through it. Tips on file names. Usually good practice to begin them with one uppercase letter, in particular for when you have two words, computer systems, capital C, lowercase OMPUTER, and a capital S. No spaces, because otherwise if I created a directory, if I said make dir computer space systems, it will make a directory called computer, and it will also make a second one called systems. So no spaces in it, because it sees that as a second command. Case sensitive, only letters, numbers, underscores and hyphens. And there's an exercise down at the end of that page with a view to your assessment. Okay, a lot of these exercises will feed directly into your assessment. Okay, redirection is on that. So I'm going to come back up now into the notes sense. That's all in the practical lab classes anyway. Your type command, if you want to find out what your command where it belongs to. So you have built-in commands, the likes of cd, ls, date, they're all built-in commands. The system, the shell has them, they're all part and parcel of the shell. So they're called built-in commands. They're built in to the shell. So a good example there is your cd, your pwd, your help, your set, your unset, any of those. The type then identifies where that comes from, what type of a command it is. So type space echo. Echo is the shell built-in. Type space cat. Cat comes from there, so it'll tell you where these commands come from. We haven't even used cat yet. We'll come to it. Is there any other Kilkenny cats here? External commands then. They're stored in files that are searched by the shell. So some of them are built-in commands, and they have their own binary. So for those, if for whatever reason you wanted to find out which command searches for the location of a command by searching the path variable. So that which searches for a location. So these external commands are searched by the shell. So that just shows you again where they are. So most of these commands are inside in that bin, that binary anyway, or sbin, or the users binary will be often at the start of it. What else is there? Your external commands coming to the end of this. Your type shows the location where it is. Your -a option displays all locations. Okay, so the -a is for all locations. Your aliases then. This is a bit more useful because your alias is basically if you have a longer command, but you know you're going to use it a lot, well then you can map longer commands to a shorter key sequence, right? As it says there up in the top. So your ls-l is commonly aliased to ll, right? So in there you can see, if you can see it's a bit small there on the screen, I could have made that bigger. If you type in the word alias, it tells you, well, here's the alias that exists. Let me see if my why I've died a slow death there. Terminal window has collapsed in a heap, stressed out in week 1. So it is. I might just actually computer system, that's grand. So you can use those alias commands. You can see what aliases are there already and you can amend them as you wish. You can add in new ones, you can delete ones that are there. So if you wanted L to mean something else and it's already has been set to, what's that, ls minus capital CF, and you said, well actually, do you know what I'd prefer it to be is, you can make changes to those. Your type command can identify aliases to other commands. So there's ll is aliased to, and it'll show you what it means instead of having to go in and search for it in there. Okay, functions then, as you can imagine, you'll be very familiar with functions by now. And as you can imagine, there are built using existing commands. You can create new commands, you can override built-in, override the ones that are built into the shell, or commands that are stored in files. You can create your own functions. Aliases and functions are normally loaded by default from initializing any files that you have. So that is any of your functions. But of course, again, as I said there the last day, I find that practically working with these will help you as well. So that is that first part of today. Let me just change my screen there for a second. Oh, where am I gone? Sorry. Right. And if I was to just change that again. So in general, going down through the notes, going down through your Netacad, you will be easily able to get a really good grasping of the content that's there. And I'm just open up the presentation for the next part. Talk amongst yourselves. No, just a second there. I'll fire this open, so I'll just have to reset my Linux as well. See what that has to say for itself. Of course, I'm opening up the wrong files. Never helpful, is it? No. Oh, sorry, yes, we're in week 1, not week 2. I'm getting ahead of myself with the excitement. Right, so when I go in now, we're moving along to being able to use quotes, because it is necessary that there'll be times when you'll need to use quoting systems for different parts of your programming. So on the each on your week 2 class 2. In here, text manipulation, the second section is what I'm moving into now. Quotes, control statements, and of course the wonderful help files that you'll all want to use. Man is the first point of call that I would go to for any of those help sections. So in here, we're going to move along to this quoting, if that's okay. What your quotes do, in general, a lot of them are used to interpret values. So using the double quotes, why is that cut so short? Right, if you wanted to type out some values, if you wanted to print values, I should say. So you wanted to print out to screen. Let me just check if my terminal window is back alive and in action again. Okay, so if I pull that down here. Very much in slow motion. I find it's a lot on my laptop when I have working with the 2 operating systems. This is my virtual machine open as well. So in here, the example that's given on the notes. Don't think it's going to work. I'll have to have a look at that myself. Anyway, you can see it on the screenshot that I've taken here. Backup plans. Your double quotes, you can see if you wanted to print out something like the glob characters are star, question mark, and the open and close and square bracket. I'm using the symbols for those. It will output, there's my echo command, so I need it to output. It outputs the glob characters are December, October, September, question symbol, and the open and closing. So what it's doing is it's interpreting the star, and it's using what's called, what I want to use is the double quotes that will stop that. So instead of being star and it represents all files and it's printing out all files, December, October, December, wherever I am, I want to print out the character star. So double quotes will allow that to happen. So in here, what's a better idea to use is when you're using the echo character, and if you want something to be taken literally, putting it into the double quotes stops the shell from interpreting any meta characters, including your globs or your wildcard characters, whatever you want to call them. I use them I prefer the word, I think glob is an ugly word, so I usually say wildcard characters. It doesn't matter. Glob characters, you can see that's what, if you're searching up online for anything either. So it's useful when you want to display something on the screen that's normally a special character to the shell. So obviously the shell looks at star and says, oh, there's the wildcard for everything. And it puts in everything. So you can type the command in. So you can put all of that. If I put it into quote marks, you can see echo space, opening double quotes. I put in my sentence and I close my double quotes. And now it is outputting more what I would have expected. So in that example, the bash shell doesn't convert that star wildcard character into the file names that match the pattern like it normally does. So it still allows for command substitution, variable substitution. So if I did need to have date written into it, we'll come to that. So it will still allow for that. Your single quotes then, and this isn't that tick mark that we used the last day. This is a single quote mark. And again, just make sure you know which is which on your own systems. So your quote mark, single quote, you can see here, prevents the shell from doing any interpretation of special characters. So it will prevent it from doing any interpretation. So if I want to say the car costs $100, this is the case where I am talking about currency. I want the quote mark to hold on to the literal value of each character that's within the quotes. So by default, the shell tries to display or to replace the value of the variable 1 with a value which doesn't exist. So it says, I've been saying up to now, when you're using echo and you can have $sign user, and it will replace the word or the variable user with the actual value of it. Same thing here. it's seeing $1. Oh, what's the variable 1 called? There is none. So it just ignores it. It said, all right, there is none. So I'll continue on and I'll print out 0, 0. So the car costs 0, 0. Lucky them. When I put in my quote marks, you can see it holds on to the literal value. It holds on to the $sign and the 1. So it doesn't try to do what's called your command substitution or variable substitution. So it doesn't try and substitute it with anything else. So it will interpret the enclosed text within the single quotes literally, and it won't interpolate anything, including variables, backticks, and some escape characters, your backslash. So it won't interpolate those, as you'll see now as we go down through this. So as I move along, sorry, there it is, my screen. Right, single quotes, backslash. Backslash character is another one. I have to try and remember myself and be careful not to call this forward slashes. So backslashes are the ones that are falling backwards, aren't they? It is used if you want to get your shell to ignore the next character to it, or just only the next variable, not a whole bunch of them. So a technique to essentially single quote a single character is using your backslash. So if I want to print out the $sign, but yet I wanted to interpolate, I wanted to convert this PATH into the actual path. So this phrase has single quotes in here. What if I just do it? I'll print it out first. When I put in my double quotes, it says the service costs, and there's a blank, because my double quotes will allow me to convert my variables. If I just go back here. So double quotes allow for command substitution, variable substitution, and permit some other meta characters. So it will allow, so double quotes will allow that. So that's why when I am doing this one here, your double quotes will allow, so it says, oh, $1. Okay, let's see what the variable 1 holds and print that out. Variable 1 holds nothing, so it prints out nothing. It has a blank. And then it says, okay, and now what's the path? So I'm in my double quotes, it allows this variable substitution. So it says, and the path is, oh, I'm calling the variable called path. Let's see what path holds and print that out, which is what it does. There's my full path. So it says the service cost, there's a blank there because $1, the variable 1 doesn't exist. And the path is, and it converts that. But if I want to actually just print out that sentence, we could use the backslash characters. So in here, the service costs backslash $1. The backslash will ignore, it'll say, right, $1. When I press enter, what happens? You want to have the path treated as a variable, but I wanted to ignore the $1. And that's where your backslash character. So it's a technique you can see up on top to single quote a single character. So a quick way of doing the single quote is to use a backslash. So if you're doing it just once in a command, and again, you'll become more familiar with that as well. So in this case, using the backslash character in front of the $signs is going to prevent the shell from interpreting it. Okay, so it prevents it from interpreting, and it will print it out as we have here. The service costs $1 and the path is. So it does a variable substitution for path, but it ignores, it says, okay, if I see a backslash, it means ignore the next character. It is not to be interpreted as anything as a special character. So if I wanted to print out the star, I could do that as well. So I wouldn't interpret it as being a wildcard character, but yet it can interpret anything else that I might have. Single or double, which ones? Single, when you echo something, the single quotes will literally echo what's between them. $signs, spaces, the and, ampersand, your asterisk, wildcard, star character. And and other special characters will be all ignored when enclosed within that single quotes. When your double quote is being used, it will evaluate variables that are between the opening and the closing double quotes. Okay, so when the single ones, there's no translation done. It's printed as is. Okay, so your single quotes, when that's used, there's no translation done, printed as is. Whereas your double evaluates the variables between them. So it will convert your $1, it says, right, what's my variable 1, what's the value of that? Or dollar whatever month, and if that contains the value January, February, March, it would reply back with your January, February, March. But it works without the doubles. In almost all situations you want to add quotes. When you're using your echo command, it is good practice to use your double quotes around it. So it's clear to your bash shell script that what's contained here is one set of characters that need to be printed out, let's say when you're using echo. So in almost all situations you want to add quotes. Enclosing them in double quotes preserves the literal value of all characters. And again, go into man bash and you'll see all of that. So man or bash does word splitting on unquoted strings. So usually when you're using the echo command, it's good practice to put some type, whichever type is most suitable, but you should put a type of quote. So your double quotes is probably the most common ones that you'll start off with anyway, until you see that it's printing out some unexpected results. So unquoted strings, it can do what's called word splitting, where it can see a tab or it can see a space and as being a meaning, and it can split a command instead of maybe the space being part of what you're printing out. So you just need to make sure then that it's not going to split your words. Your backquote then are used, we've used it already, and to specify a command within a command. So we have the output of echo. Echo today is date. There is today is date. That's grand. It printed out a string of characters. That's what it was told to do. But if you have a command such as date within a command that is echo, you can tell it to replace your date with the actual value of it. So the output of it is just the line that we have here. So to execute your date command, you can put it into, are they called, I'm saying a tick mark, are they called back quotes? Falling backwards? I think so. So you have your quote marks, you have your single quote marks, and you have these back quotes, but I usually call them ticks because too much use of the word quote is too confusing. So you put that inside your little tick marks then, and it should reply back, and it will reply back because you've used it already, with replacing DATE with the contents of that shell variable. I'm saying a shell variable because you, the user, me, I don't set that. I don't go and keep changing the date and time and the seconds. That's part of the system, isn't it? Control statements, again, so yeah, quote marks will take a bit of getting used to. You'll get there. Control statements are the likes of being able to run more than one command on a line at the same time. Semicolons, you have the double ampersand or the and signs, and you have a double pipe. Remember that pipe that I was figuring out where it was on my screen or on my keyboard? That's what we have here, is that double pipe. And what these, so that's like your and. So I want to do one command and follow it along by completing the other command. Or I can do one command or another command. Let's see. Semicolon, running one after another. So I can run the calendar for calendar 1 for 21, calendar 2. So if you have your screens open, and if you have a calendar on it, let me just see. Back into the matrix. Why that's not actually. Am I out on this? Oh, hang on now. It's selecting on the screen. Select all. Aha. It was in the background. Silly me. Anyway, if you have a bunch of stuff on your screen, you can click on clear if you want to tidy it up a little bit. Do I have a calendar? I do. So if I did calendar 1 of 2024, it will show me for January. If I wanted to do more than that, I have calendar 1, and then I'm going to run it with calendar of month 5 for 2024. And then I want to see how's my holidays going to look for next July of 2025. And I can run all of those. Oh, I did calc instead of cal. Now, and there, it runs one after another, as you can see there. Your double ampersand then, the difference with this double ampersand, it acts as a logical and, you know, your logical ands and ors. So if the first command was successful, then do the next one. So in that case, you can see I can run my first calendar, and if that's successful, if there wasn't any issues with it, I can tell it that, and I want to run the second one. So we'll only perform the second one based on a successful outcome of the first. So there you have listing some contents for the example that's on the notes. The double pipe then is a logical OR. So it tries to list something, it'll do that, or it will echo fail. So it works similarly to AND depending on the result of the first, so it'll either be run or skipped. So in that case, because there was a fail, it replies. So it'll come to the second one if the first one fails. So you have your logical ANDs and your logical ORs and your multiple commands. That's where your semicolon for multiple commands, your AND is your double ampersand, and your OR is the double pipe sign. And of course, we need our help pages, the first one being your man, not your man. Your man pages, manual, M-A-N for manual. Navigate your document, just use your up and down arrows, fairly straightforward. There's here we go. So if I had man and I wanted to do man echo, right, there's my echo command. Tippity tap tap. Allows me to see all my optional arguments that I might want to use, my backspace, my escape, and all the rest. Loads of reading, the authors, the copyright. I'm nearly down at the end now anyway. Q to quit will allow me to quit out of it. Similarly, if I wanted to say, well then, what's printf going to be used for? And there, formatting allows me to format some of my data, so it might be a tidier output. Oh yes, that's the difference there. Scrolling down through it, that's grand. Q to quit. It's broken into different sections. All of the manual pages are broken: name, synopsis, description. So there's where it'll give you all of the optional arguments that you can have for it, and then we're at the end once you can see as far as the author. Okay, basic description of all of those. If you want to search the manual page, so sometimes there can be something long in it like this. If I go back into my man printf, and as I'm going down here, I could say, oh, there's carriage, return, vertical tab, and all the rest. And now sometimes these are very long. And I'm saying, oh, can I do a search? I know I saw the word return in there somewhere, or carriage. If I do the forward slash, not the backslash, and I put in the word carriage, I-A-G-E, pattern not found. I thought I saw it. T-U-R-N, return. Why? Q to quit. Oh, there, it highlighted it. So in there, you should be able to use it by searching for your term with your forward slash. Pressing N then should allow you to move along. Finding documents. Where did you put a document? What folder did I put that in? Can't find it. Searching for the location of a command, or the man page for a command, you can use the where is. So it searches for commands, source files, and man pages in specific locations where they're typically stored. So you can ask it, where is my ls command? Okay. If you want to find, that's grand, you're finding commands, but if you want to find files or directories, which is probably more common, where did I put that file? To find a file or a directory, you can use the locate command. The output, again, depending on what you're doing, it can be quite large. -C will do a count. So it will list how many files match it and whatever the word might be. So in this case, I'm going to queue for quit there. And I'll say, where is locate SEBT? There's locate September. Oh, I have to install it first. Sudo apt install plocate. Anyway, so look at you'll see those from there. And again, you can go to the man page, or you can type help and the word locate, and it'll show you all the options. So to find any file, you can use that locate. So it searches a database for all the files and all the directories that were on the system when the database was created. So any files created that day won't be searchable within the locate, because usually that's updated overnight. You can use the updated B command as an admin to update it, just so that you can read all of the most current files that you might have. So you can again use your little options like your -C, which will do a count. -B only includes listings that have the search term as the base name of the file name. So you can use whatever commands go into your manual and you'll see those. So that brings us to the end of the set of notes for today. What you have to do then, I'll just squeeze back in here, is in your labs, working down through it, redirection allows you to redirect whether it's the output of some file. You can get it to redirect the output of a file, or you can get it to redirect the output to an error file, or redirect it to a printer, and so on. So in there, if you have a look, instead of it going to the standard output, you can redirect the output into a new file or into wherever you want it to go, into a memory key if you want it. So there's your structure, there's changing your directories, there's listing where you are, and instead of listing it to the command prompt that we're looking at, I want to say, well, if I list that out every morning and see who's logged in at 9 o'clock, I'm going to get it to save that file in case I'm not there to see the output. I'll get to save that file, and I can do that by running or by redirecting the output into whatever the name of a file is, output.txt. Cat is used to see what's contained in a file. So if I have a file like what we had, I'll just control C that because I don't really mind where we are with that. -L. I'll change it to September. And first script, if I just wanted to see, right, what's in that first script, I can put in my cat, and I'm just going to do FIR because I'm only looking at, there's only one file that begins with F, so I could just do cat F and a star, and it will concatenate, in other words, allow me to view or to read what the contents of that file is. And that's all that's in that, is just the author and the description. How do I know that? Because if I'm after concatenating it, I can nano and I can see what's in it. Oh, there's what's in it. Here's my temp file to get going. Now I'll save that file, save it, yes. Yeah, first script. And now if I do my cat, you can see there's my new piece of content. Here's my temp file to get going. That's what the concatenate is used for. Redirecting output, you can redirect any output into any file. Or when we get more comfortable, you can redirect any output into another file. So you could run a command and the output of it, like the who command, and you could say, so if I did my who command and it shows that I'm logged in, but I want to store that. So, or what about if I want to do my who and my date? There's all of that. If I want to say, well, do you know what? I'm going to get those to be put into who's logged in .txt, right? Doesn't matter what my file extension. Linux doesn't care if I put it as a .txt or a .wyz, right? If I go into that, and now I can should be able to see if I just do my concatenate and see who's logged in, and there's my contents of that file. If I go into ls, there's my who's logged in. I can go into nano, my file, and you can see what's after happening is that my output has got there from 1340. The output of my who and my date has been redirected there. Okay. Wildcards, that's usually your star. If you are passing, you can see here, some of this runs into next week anyway. Your question mark for a single character. So if I want to see, is there a file, and we'll be doing more examples of this in the practical work. Is there a file that has 3 characters on it? Is there any file with 3 names? I can do a search for just question, and that's specific. Your asterisk is for any, doesn't matter what's after it. So that just represents anything. And your square brackets, then you can have a range. So obviously this is used for ranges of letters from A to Z or numbers. So if you're searching for, or if you are requiring that users put in their phone number and it must be X amount of characters long, then you can specify that by using the square brackets as a range. And again, there's some examples there. There is the output of the who. Check that now. Under your append, then, when you have your 2 arrows on it, it means it's different to your file redirection, which brings me back in here. My file redirection is when I have cat who's logged in. So I have that in there. If I decided that, well, actually, I'm going to do a check and I'm going to add that. If I want to add it to a file, I'll just use the single arrow, because what the double arrow does is it overwrites everything. So it will overwrite all of the contents of a file and it'll replace it. So fine if I want that to happen, but it's just to be aware that if you are adding on information, then it's this double arrows that is what you want to use. So you will append rather than replacing it. So if you don't want to overwrite things, which is probably the most common way, where you want to have additional information in it, you have your double arrows. File manipulation, then again, you can go through that using your touch command to just set up files. Maybe you don't actually have anything in them. You have your concatenate files. So there you can see all of those. And viewing larger files using the head and tail in there. Being able to print out the first 15 lines, being able to print out the last 15 lines. Have a look at the commands that we've got in there. And then executable scripts. When you're creating a script, you should have your shebang line, that $# /bin/bash, and then your comments. You should have a comment, as is good practice with any program. You should have a comment in there to describe briefly what your file is all about. And now, here's a little bit of practical work. And again, it is with a view to you being able to program comfortably without too many errors at the very beginning. So permission denied, any errors, review your code, fix it, what's happening there. Quotes, try out the different types of quotes. Again, like I said at the start of class, really the best way of understanding quotes properly in particular is just experiment. You're just using the echo command. You're not going to explode the computer or anything like that. So just basic commands like this, hello world, but just using the different quotes, you'll get to see the different outputs that you get from them. Write a piece of code. You want to output the exact text. Another day, another dollar. Exclamation, exclamation. What is going to be an efficient way to do that? And I want you to type out, because here, if I just print this, type it into my here. So I can say, here's how we can use single, and double, QUOT, yes. Within double quotes. And when I print that out, here we can see in here what's happening. What do I want it to do? So I'm just giving it a piece of text so it doesn't actually know. So for starters, obviously, I'm going to have to, I am going to need to echo my command, right? And here, try it out. So I'm going to echo that. Oh, I've doubled it up there. Now here's my echo. So it still doesn't know what's happening here, so I'm going to Control C. Firstly, you need to put, it has so much information there. There's tick marks and special characters that your bash will be trying to interpret. So if I put it into double quotes, it's still having errors on it. What's happening here is the fact that it is looking at these. When I'm putting in there's my little first one. It sees these as special characters and is getting all confused. So instead of suing, I can use, that's spelled wrong, USE instead of SUE. All right. And again, it's just a matter of thinking about, well, okay, going one at a time. Which quote marks can I use? Which escape characters can I use? That's going to help me print this out exactly as expected. Okay. Have a go at that. They're just nice ways of getting a bit more comfortable. So in summary, there's a bunch of commonly used phrases, commonly used commands, and the use of them. So when would you use them? Each of these you will become familiar with because you'll be using them a lot. There's your double quotes, there's your single quote, there's your backslash, there's your back quotes, then the little tick marks if you want. Your touch command, cat, head and tail. And now add system information to your num users. You should have a num users file if you've got the first class completed. And in that, what I want you to use is extract and output any system information such as, so you want to see any of the information, we're going to add it into our command. So any of these, doesn't really matter which ones that you use. So if I wanted to echo, let me see what ones are there. The hardware info. Oh no. What's my mistake? I hear you shouting. Put in your $signs. Oh, there's no, I haven't got my hardware info there. I'll have to see if that's out of place by now or outdated. So we should be able to find our hardware information then for our computers. And what you want to do is to be able to print out some details, adding it into that script. And again, making it executable, making it user friendly. Okay, so that an end user can read it. So execute the script. Creating a template. Because you're going to be using scripts, you're going to have your shebang line. You're going to have a space for your author. You're going to have the third line with the word description and a colon on it maybe. It might be a good idea to create a template. Simply called template.sh, and you won't have to remember any of the, which one is it, backslashes or forward slash in that bin bash. You can store that into where your files are and you'll be able to reuse it then. So that's all, just a shebang line, some introduction, your name, student number, space for comments to describe it, check the file is executable, check the file permissions then. And this is a nice page, one of many now, this Ryan's tutorial online. If you wish to go in there, welcome. So it gives an outline, there's inputs, if statements, for loops and all the rest. We will be coming to those. But you might find some useful information there, and it's written in a very easy to follow way. Share your resources on Slack. Feel free to sharing anything that you might have. And then for your Netacad, the homework part, that would be a good advantage for, in particular, as I said, anyone who's new to it, but I do want everybody to complete them. Chapters 5, 6 and 7. Okay, so week 1, the main homework is a few little executables that you've got there. You do need to practice in terms of the practical side of things. And other than that, it is the Cisco NetAuCAD, getting chapters 1 to 7 inclusive, and the chapter exams done for those. Okay, so I think I'm going to leave it at that and jump onto Slack then in the background. So thanks a million to everybody, and I hope everything is going well. Look at the usual old ding dong. Keep an eye on Slack for comments and messages that I put up, that your classmates put up, and help each other out on that. Right? Thanks a million, everyone. Hope that's all makes a bit of sense to you anyway. We'll get there. Week 1, so don't worry if it seems all a bit overwhelming and there's so much being thrown at you. It's because as you go down through and you start practical work, that you'll be using a lot of these. So it's building the foundations. It's giving you an understanding before we get going. So well done. Keep up the work.